Hello everyone, I'm João from That's Brilliant, and this video is another video on calculus. So in this video, we're going to prove the derivative of sine, of the sine function. So we're going to do this mathematical proof in a way very similar to the way we did the mathematical proofs of the other derivatives that we proved in That's Brilliant. So we're going to start with the definition of derivative. So if we have a function f of x, the derivative of this function, which is f prime of x, is given by the limit when h approaches 0 of f of x plus h minus f of x, and all of this divided by h. So this is the definition using limits of the derivative of a function. And we're going to apply this definition to the sine function so that we can prove the derivative of sine. So in this case, f of x is sine of x. Sine of x is the function of which we like to calculate the derivative. So if f of x is sine of x, we're going to continue doing what we are doing. We're going to apply this definition to sine of x. So this is equal to limit when h approaches 0, and if f of x is sine of x, f of x plus h is equal to the sine of x plus h, and then minus f of x, and f of x is sine of x. So sine of x and divided by h. And now we're going to use a sum to product formula, which is basically a trigonometric factorization. We're going to transform this sum or subtraction into a product, and we're going to use an equation that we study when we study trigonometry that says the sine of A minus the sine of B is equal to 2 times the cosine of A plus B over 2 times the sine of A minus B over 2. This is one of the sum to product formulas. We're going to use this function here because we have one sine minus other sine. So let's use that very formula right there. So we have the limit when h approaches 0, and then 2 times the cosine of a plus b over 2. Let's here identify what is a and what's b. So a is this right here. A is x plus h. It's the argument of the first sign. And x is b, the argument of the second sign. So a plus b is x plus h plus x. So this is 2x plus h. And this right here is just a plus b. After that, we have the divided by 2. So here, divided by 2. And then sine of a minus b is x plus h minus x. So x cancels out with negative x, and we have just h. And then divided by 2. And all of this divided by h. So moving on, we have the limit when h approaches 0. And here, we're going to kind of manipulate things so we can simplify this whole thing. So if we look at this sign here, we have sine of x, sine of h over 2, and we have a divided by h. This reminds us of a famous limit, which is the limit when x approaches 0 of sine of x over x. This is equal to 1. So sine of h over 2 divided by h is very similar to this, but we need a divided by 2 right here. So this thing is equal to the argument of the sine. We can do that. We can divide both the numerator and the denominator by 2. So if we divide the numerator by 2, this 2 cancels out. And the denominator divided by 2 is h over 2. Now we're going to use a property of limits. So it's a property that says if we have the limit of a product, this is equal to the product of the limits of the two factors that were being multiplied before. So let's write it that it gets clearer. So this is the limit. The first factor is the cosine of 2x plus h over 2. So limit of cosine of 2x plus h over 2. And then we're going to multiply by the limit of when h approaches 0 of sine of h over 2 divided by h over 2. So we splitted this limit up. So this is the first factor, this is the second factor. We just split the first limit. And this is one of the properties of limits that we can use here. So this limit here is 1. You can say, well, but this h should be h over 2. Yeah, but it's the same thing. When h approaches 0, h over 2 approaches 0 as well. But let's just prove this more correct mathematically speaking. So let's just do this part right here. So let's say that h over 2 equals u. So when h approaches 0, u also approaches 0. So this limit here is the limit when u approaches 0, h approaches 0, u approaches 0. So this is the limit when u approaches 0 of sine h over 2 is u. So sine of u over u. And now this is clearly 1. Here x, 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 u, u, u. So this is 1. So we have proved that this is 1. This can be ignored because multiplying by 1 doesn't change anything. So we are left with just this limit right here. So moving on, we have the limit when h approaches 0 of cosine of 2x plus h over 2. And we can already solve this right here. Because when h approaches 0, this h is approaching 0. So this whole expression approaches cosine of 2x over 2. And this is exactly cosine of x. And we have just proved that the derivative of sine of x is cosine of x. So you can write, if you want, that sine prime of x, the derivative of sine, equals cosine of x. Or ddx of sine of x, which is just the derivative of sine of x, is equal to cosine of x. And this is the proof. This is the point of the video. So thank you very much for watching, and I will see you in the next video.